How does the web work? Now, maybe you're now thinking, well, what's this question? Of course I know how the web works. Well, maybe you do, but maybe you're also leaving out some important parts. In this video and in the article which you find below the video, in the video description also, I will have a look at how the web works, which different pieces are involved, and how that influences what you, if you want to become a web developer or if you're simply interested into the topic, should learn and should be aware of. Now, as always, if you're liking this, I'd love to welcome you as a subscriber. Please share the video and the usual stuff. With that, let's lose no time and dive right in. With that, let's start with the most common scenario. You're visiting a web page, like our web page, academind.com. So you fire up your browser, you enter https www.academind.com or maybe just academind.com, and the browser adds the other parts, and I'll come back to that in a second. Now you expect the website to show up on the screen, but what is actually happening behind the scenes? Well, the website is stored on some server. So the website you're seeing is either generated dynamically there or the code for it was actually stored there already and is returned back. Because your browser in the end is just an interpreter, you could say, that gets back certain source code, to which I will come back in a second, and it can display that on the screen. And that source code could either be stored on the server already or it's generated by the server. But one important question at this point of time already is, how does the server know that we do mean it, the server, by entering academind.com? Is this the address of the server, just like your street and house number is your address? Actually not. The official address of each server is an IP stands for Internet Protocol, address. And an IP address looks something like this, or in a more modern version like this. This is of course not something you would want to enter into your browser, but you could do it actually. You could enter such an address, if you knew it, into the browser and visit a website with just that address. But of course the domain, as this other thing here is called, is much more human readable. And therefore the actual first thing that happens when you enter this is that your browser contacts a DNS, domain name system server, which is basically like a huge dictionary where each domain name is mapped to an IP, you could say. And then, therefore, this DNS server translates your academind.com domain into an IP address. This IP address is then given to the browser, and with that, the browser can actually make that request to the server which has the IP address. Then there, as I mentioned, we generate the source code for the website, and then this is sent back to the browser where this website is now displayed. That is how this works in a nutshell. Now the part where you enter the URL, so academind.com, and you send this off to the internet, that is called a request. The browser makes a request for this page. And a request is like a package of data where this URL is one part, but another part would be the type of request, because it turns out there are different types, which you, for example, use for getting a website or for storing some data in the web. So if you submit a form, you send a different type of request, for example. A request could then also include that data you want to send, or it includes no data if you're only requesting something or you only want to get something. It can also contain some metadata, so-called headers. And you can always have a look at a request if you go into the browser, open the developer tools in there, which every browser has, and then in the network tab, you inspect the request that is being sent. And there you will see all the metadata and so on that was attached to the request. It's always interesting to see that. Now what you're getting back is a response. That is also a data package in the end, and you can also inspect that. And this also, again, contains some metadata maybe, and most importantly, for a traditional website, the HTML code that should be rendered. HTML code is something we haven't heard before, but that's essentially that source code that is displayed or that is turned into what you see on the screen by the browser. And that takes us to the involved technologies already. What you see in the browser is the result of a combination of HTML, CSS, and JavaScript. These are the three languages or technologies involved in getting onto the screen what you see. Now, HTML stands for hypertext markup language, and that gives a website its structure. It doesn't say anything about the styling, it just says what should be a heading, what should be a paragraph, what should be an input, what should be a button. That is what you say with HTML. And the browser is able to read that because it's a standardized format. Now, of course, a website should also look good, and that is done with CSS, which stands for Cascading Style Sheets. CSS is responsible for turning a text red, giving a button a certain look. And you as a developer can write that CSS code just as you write the HTML code to get the result you want. By the way, I also mentioned that a server might generate that dynamically. With that, I meant that it might generate the HTML code dynamically, and that with that, it actually gives you a different code back for different requests. That is something an online shop needs, for example, where you might want to display the cart content. This is part of the response, and that is only possible if that response, that HTML code, is generated dynamically on the server. Now, we're not diving into how this works here, but you as a developer, if you're building that website, you simply define rules on how the code should be generated, how it should look like, and when which code should be generated. This is all we need to know right now. The third language that is involved is JavaScript, and JavaScript is responsible for all the logic, all the dynamic things that happen in the browser. If you have a drop down, if you have tabs, if you have like that overlay that opens sometimes, or a sliding in navigation, that all is powered by JavaScript. It's basically responsible for everything that changes in the browser after the page has been loaded. Now, all that data transfer, as I said, is also standardized. It is, for example, standardized how a request and response should look like. That is all defined by the technology used, which is HTTP, which stands for Hypertext Transfer Protocol. There also is HTTPS, which is the same just in an encrypted form, and all modern websites, including Academind.com, use HTTPS actually, so that all data is encrypted. Hence, the request data you're sending and the response you're sending is end-to-end encrypted. So the browser and the server know how to decrypt it, but in between it's encrypted. And if someone were to sniff your connection, which is technically possible, then these people will only see some unreadable content. So they can't read which data you are sending or which data you are getting back. This is what HTTPS is. It's a standard that defines how a request should look like, and in the case of HTTPS, that it has to be encrypted. And the encryption is then done by the browser and by the server. So these are the core technologies involved. There also are more technologies because, for example, if on the server side we're generating this page dynamically, then this of course means that on the server side there needs to be some code that runs. And that is done with languages like Node.js, PHP, Python, and there also are frameworks that could be used there. Frameworks are basically packages of utility functions that also give you some rules on how to use them that make writing code simply easier, because you don't have to reinvent the wheel for all the nitty-gritty details. You can focus on your business logic, and things like parsing incoming requests and so on is done by such a framework, so that you don't have to manually go through all the lines of an incoming request. You instead just get the finished parsed data, and you then write the logic what to do with that data, instead of writing the parsing logic, which would always be the same. Such frameworks, by the way, also exist for the front end, where you might have applications where a lot of stuff is happening with the help of JavaScript to provide a nicer user experience, where you don't always need to fetch new pages for every click the user does, but where you want to show an overlay, where you want to change content on the page while the user is on the page. And that is then also made easier with such frameworks, for the same reason as on the server, that you don't have to write the logic on how the change happens on the page, but instead you just write the logic for what should change when, and the framework takes over and does the heavy lifting. So frameworks also an important part of web development, but of course a part that is typically hidden away from you if you're just visiting pages, just as the other technologies, I guess. Now that is how the web works in a nutshell, but the web is more than just traditional websites. It's more than just HTML code getting sent back and displayed on the page. And with that, I mean that, for example, if you're having a mobile app, Twitter, Facebook, Instagram, doesn't matter, you also, of course, have content that's not stored on your device, but somewhere in the internet. Let's say pictures posted by other users. There, you don't actually get back HTML pages that contain these pictures, but instead only data is exchanged. And it is important to understand that with the web, we don't just mean websites, but we basically mean any interaction where you have some computer called a server, which sits somewhere out there in the internet, not in your room, and you're communicating with that server, not actively but inactively, so indirectly. Your app communicates with that, your website. A website might send a request, get back a response with HTML. Now that request-response pattern is always the same, but actually a mobile app, for example, sends a request but doesn't want HTML as a response, and it clearly says that in the request. Instead, it wants something which typically is called JSON data. That's a specific data format, and we don't need to dive into the details there right now. But there, the server responds with a data package, which is not parsable by the browser, so it's not something that would be converted into a visual website by a browser, but by the app. The app which people wrote, like Instagram, the source code behind the app, knows how to parse that incoming response and how to handle that. If that, for example, are 5 new posts by people you're following, well, then that is converted into something you can see on the screen with the help of the source code written by the developers of the app. So that is also where we have the internet. Same request-response pattern, but the data which is exchanged is different. It's not a HTML page, it's another form of data. So the data format is flexible. The core idea that we have code running on a server and code running on our device, no matter if it's a mobile phone or if it's a browser, that core idea is always the same. Now, there also are more advanced technologies, for example, for real-time communication, where you don't have request-response, but where the server can actively push a new message to the client. So the client never sent a request, but gets new data anyways through an established connection with a technology named WebSockets. But that's even more advanced. It exists, though. I hope that nonetheless with this, you might have learned something which you already knew. Well, doesn't hurt then. I hope I didn't steal too much of your time, but you also might have learned something which you only vaguely knew before, which now is a bit clearer, hopefully. Hopefully see you in other videos too. Bye.